Hi, in this session we will derive expressions for trigonometric functions of sums and differences of two different angles. Now, let us look at this unit circle out here and let us draw an angle denoted by capital X by something like this. We'll write it as capital X just to differentiate it from this positive x-axis here, which is shown by a small case. And let us call this point E. Therefore, line segment OE makes an angle of capital X with the positive x-axis in the counterclockwise direction. And on top of X, let us add another angle Y. So this angle out here is Y, and let us denote this particular point by F. So OF segment makes an angle of X plus Y with the positive x-axis in the counterclockwise direction. And now on the negative side from the positive x-axis, that is in the clockwise direction, let us make an angle that is equal to y. Let us say this one out here, okay, and let us call this point as G. So line segment OG makes an angle of minus y from the positive x-axis. That is, this angle is y in the clockwise direction from the positive x-axis. Now let us indicate the coordinates for these points A, E, F and G. Now we know that point A lies on the x-axis and it is a unit circle, so the coordinates of A are 1, 0. The coordinates of E are cos x, which is a projection of OE on the x-axis, and sin x, which is the projection of OE on the y-axis. Likewise, the coordinates of F would be, let's write that here, cos of x plus y and sin of x plus y, right? Because OF makes an angle of x plus y with the positive x-axis. And likewise, the coordinates of G would be cos of minus y and sin of minus y, because it makes an angle of minus y with the positive x-axis. Now let us look at these two triangles OAF and OGE. These two triangles are congruent. You will realize that by looking at their angles and the two sides. The angles AOF, which is x plus y, and the angle EOG, whose magnitude is also x plus y, are equal. And the two adjoining sides, that is OA and OF, are both equal to 1 because this is a unit circle, and so are the sides OE and OG in the triangle OEG. So therefore these two triangles are congruent, and therefore their third sides would also be equal, which is the side AF would be equal to side EG. Now because we know the coordinates of all of these points, that is A, F, E and G, we can write the expression for the lengths of these sides A, F and EG, and if you equate those two lengths, you can arrive at the expression for cos x plus y. We will not prove that expression here, you can prove it for yourself, but we will write the conclusion, which is cos x plus y is equal to cos x cos y minus sin x sin y. Now if you substitute y with minus y in the first expression, you can derive the expression for cos x minus y. Simply substitute y with minus y. So here it will be cos x, and cos minus y is cos y, as we know, so this will not change. But sin minus y is minus sin y, and sin x is sin x, so this will become a positive term, sin x into sin minus y, which is minus sin y, so therefore plus sin x sin y. And let us now try to derive the expression for sine of x plus y. Now we know that this is equal to cos of pi by 2 minus x plus y, because we know that sine theta is equal to cos pi by 2 minus theta. So therefore sine of x plus y will be equal to cos of pi by 2 minus x plus y. And now we have an expression here which is similar to cos x minus y, because we can write cos pi by 2 minus x plus y as cos of pi by 2 minus x, that we'll write as one angle, and minus y as another angle. So we will substitute in the expression for cos x minus y. In place of x we will use pi by 2 minus x, and in place of y we will use y. So therefore this is equal to cos of pi by 2 minus x into cos of y. Now cos of pi by 2 minus x is sin x, and cos y plus sine of pi by 2 minus x, which we know is cos x, into sin y. And now we can write the expression for sine of x minus y by simply substituting y with minus y in the expression of sin x plus y. So this becomes sin x into cos minus y. Now cos minus y is cos y, so this is sin x cos y plus cos x into sin minus y. Now sin minus y is minus sin y, so this will become minus cos x sin y. Let us now go to the next page and derive the expression for